How did we do it before?
When we solved for x2 before, right? And then plug that equation into equation 3 and eliminate it.
The first example that we worked through, right. But then when we've been doing it here, what were we doing? We're going to take
We'll slide 3
into the pivot. Yep. So we're going to take 3 times the pivot and subtract it from equation 3. And that'll get rid of that term that we're trying to eliminate, right? Because 3 times 10 will be 30. And if we're subtracting that from 30, so that'll be 30 minus 30. So that'll go to 0. And then if I have 3 times 25 is going to be 75 minus 20 minus 25 is going to be what? Minus 95. And then 3 times 9 is 27, so 270, and 80 minus 270 is going to leave me with 270, so what, minus 190, right? Is everybody tracking? Is that making sense? Is you getting what's going on? So now if I rewrite this matrix, so this will be 1, minus 1, 1, 0. And let's see. So this will be 0, 10, 25, 90, 0. This is going to be 0. We said this was minus 95, minus 190. Right?
Weren't we just minusing all the?
Yeah, isn't 95 supposed to be positive?
Yeah.
Minusing a minus?
I have minus 20 minus 75. So minus and a minus.
Row 3 minus row 2.
Yeah.
Okay.
Right. Because I'm subtracting 3 times the pivot from row 3. And row 2 is multiplied by 3, right? To get rid of that first term in row 3.
So if you multiply 10 by 3, it's
I know, it's kind of, takes a little getting used to. But see, now we have a triangle, right? And which is what we're shooting for. Trying to get a triangle. Because that means this is x3, right? Equal to this. So I have one unknown for this equation, and I can solve for what x3 is. And then plug it back in up here, solve for x2, and work my way back up, right? Does that make sense? So if I write that out over here in equation form, x1 minus x2 plus x3 equals 0.
Professor Pringle, can you explain how we have a negative 190 and a negative 95? How are you doing that?
So I am subtracting the pivot row from the row, my elimination row, or let's see, so this is row 3, right, minus row 2, or well, 3 times row 2. So when I say 30 minus 3 times 10 is 30, so 30 minus 30 is 0. and I say 3 times 25 is 75. So minus 20 minus 3 times 25, so that's minus 95. And then 80 minus 3 times 90 is minus 270, or 3 times 9 is 270. So we did the same thing. We did the same thing on that first time that we were going through, right? We're doing row 2 minus row 1, row 4 minus 20 times row 1. Okay. So now, oops. So we've got what? X3 equals minus 190 minus 95 equals 2, right? And we were dealing with amps when we started with this.
Is that a 4?
So we can take that back to our original graph chart, or where we started, right? Plug those numbers in and it'll sum out. Okay. So, a wee bit confusing, I know. Let's see. So questions. For Adam and Chelsea, you might have to kind of go back and restart the video so you sort of catch up where we are. And Michael's an expert, so
Oh, yeah.
he can.
You just scroll up to like the first part we started. Yeah, right there. Perfect.
So we need to practice a bunch of these, obviously.
I would practice a few, and I will assign a few as homework problems so that you can, yeah, so you have an opportunity to practice them. Because you'll want to be a little bit familiar, because you will get a Gaussian elimination question on the test.
And we can choose either method, whatever we feel most comfortable.
Whatever's you're most comfortable with, yeah, is fine. It's not a,
Are you gonna give it to us in the form like that, where we have to decipher where to put all the?
I think you get both. I don't remember. And I'll probably make up something different anyway, so. Whatever kind of mood I'm in at the time. For sure, you'll get one with, like the first one we did, that was just a list of equations. Because then there's no, that's going to demonstrate that you know how to, so one of those types of questions with the 3 equations or 4 equations already listed out is what I would be testing when I do that is, can you do the Gaussian elimination? Can you go through that procedure and do the process? If I'm giving you a question more like this, I'll probably tell you to set up the equations and won't ask you to solve them. The concept being, can you look at this and determine, what are the series of equations? And then not have you solve them, because if you set up the equations incorrectly, then you're going to get an incorrect answer. And so I'm testing two different things by asking those questions. So does that make sense? Okay. So did I get what you needed, Michael, on this, or is that making sense? Okay. So here's another example. Let's see, I'll put this over here for a second so we can see the example. Right. So let's see if we can set up our series of equations for this one. So how might we go about this? Or what do you think?
Could we look at the 4 intersection points and just analyze those just like
Right.
this?
Perfect. That's exactly what we're going to do. You want the intersections to be what we're going to call nodes, right? So this is beginning to, transition to what we're going to deal with as far as our FEA, our elements and our nodes. So we're going to use the intersections at nodes, right? And again, we're going to claim that whatever goes in has to come out, right? We have to have conservation of nodes, whatever you want to call it, right? You can't have, 600 cars go into the intersection and only 200 come out, because we can't have a black hole in our node, right?
Or the street.
Or the street, or a big hole, so yeah, maybe there is a big hole, a big sinkhole in the street, but we don't want that, and we're going to pretend that there's not one. Okay. So if we set this up, let's see. Well, I'll put.
And these are one-way streets, right?
It's kind of looking that way, isn't it? They both. Oh no. No, they're all. Oh, yep. Thanks, Zach. So these go like that. Okay. And so what we have 600 here. Let's see. This is x1, x2, x3, x4. Okay, so let's see. So let's label our nodes here. Work our way around the. Oh, did they do it? Okay. So, how do we want to do node A? What's that going to look like? What's our convention going to be? We should define that first, right? Because we have, this is car, yeah, traffic flow. Well, I guess, well, traffic, that's cars. So we have traffic going in and traffic going out. So what do we want to call our convention?
Right and down is positive and left and
Well, we're dealing with the node itself.
What goes in is positive, what goes out is negative.
Negative, yeah. So if we say into the node is positive and out of the node is negative. So for node A, what would we write?
400 plus
600 and 800.
minus x1 minus x4.
So yeah, 600 plus 400, then what?
Minus x1 minus x4.
Minus minus x4
Does that equal,
equals what? Right? 0, because we're our conservation of cars, right? So B, node B